Hello everybody, this is the second lesson of our cryptography course. This week we are going to start studying classical cryptosystems. Before we begin to study classical cryptosystems, let us give some definitions that we are going to use during our course. So, we will start with defining the term cryptology. Cryptology is the art and science of preventing users from unauthorized or illegal actions toward information, networking resources, and services. This definition is actually a classical definition of cryptology. When we talk about unauthorized access prevention, we actually mean that we are going to use cryptosystems to ensure it. That is, cryptology is a science that studies ciphers. We have some information and we need to guarantee its confidentiality or integrity or its accessibility while storing it or transmitting it through an unsecure channel. To ensure data confidentiality, we use cryptographic transformations. Cryptographic transformation is conversion of input data into output data using a cryptographic key. So, the input data is referred as open text or plain text. This is the text that we will be encrypting. In other words, this is the message that we are trying to prevent from being read by other people. The output data is our ciphertext. Finally, the key is some information that is required to encrypt or decrypt our message. Of course, the key should be kept secret. Another term that we will operate on is term cryptosystem. And we can define this term as follows. Cryptosystem is stored and inverse cryptographic transformation pair. That is, by cryptosystem we mean a pair of algorithms, one of which will transform plain text to ciphertext, and another algorithm will do the inverse transformation. So, when we talk about cryptology, we usually talk about two parts of which this science consists, namely cryptography and cryptanalysis. Let's define what is cryptography and what is cryptanalysis. Cryptography is a method of storing and transmitting data in a particular form so that only those for whom it is intended can read and process it. Cryptography consists of mathematical methods and aims on ensuring the basic purpose of information security. And when we talk about purpose of information security, we mean confidentiality, integrity, authentication, and non-repudiation. That is, cryptography is a part of cryptology that is responsible for developing the encryption algorithms. So, cryptanalysis refers to the study of ciphers, ciphertext, or cryptosystems with a view to finding a weakness in them that will permit retrieval of the plaintext from the ciphertext without necessarily knowing the key of the algorithm. That is, an attack on ciphertext is called cryptanalysis. That is, cryptanalysis, in the contrast, the science in which we are trying to find the weakness of developed encryption algorithms. These weaknesses can be due to vulnerabilities of the algorithm itself or the mathematical problems on which this cipher is based. So, prior to this, we have mentioned about confidentiality, integrity, and accessibility of information. There are two more terms that we are also going to use in the theory of information security, which are authentication and non-repudiation. So let's define these terms as well. Privacy or confidentiality. means that unwanted person should not understand the encrypted information. Integrity means that information should not be altered while transmission. Authentication means that sender and receiver must verify the identity of each other, and non-repudiation means that the sender cannot deny that information has been sent by him or her. So, after we have defined all these terms, we can talk about encryption process itself. So, encryption is a conversion of data into a form called a ciphertext that cannot be easily understood by unauthorized people. Decryption is a reverse process to encryption, that is the process of transforming data that has been rendered unreadable through encryption back to its unencrypted form. So please note that under unauthorized access we mean access by people who do not have a key to the cipher. So when we talk about cryptosystem, we mean the set of encryption algorithm and decryption algorithm. Using these algorithms, user can encrypt the message with encryption key, and output of this transformation is going to give us our ciphertext. The ciphertext is usually sent to receiving point via unsecured channel, where we use decryption algorithm and the cipher key to obtain our plain text back. So we can define a cryptographic communication as a collection of 5 elements, which are encryption algorithm, decryption algorithm, plain text, ciphertext, and cipher key. Thus, if we use mathematical terms, then by cryptosystem we mean a 5-tuple P, C, K, E, and D, where the following are satisfied. First of all, P is a finite set of possible plaintexts to be encrypted. That is, as we see, this set is only limited by the number of words in the human language. C is a finite set of possible ciphertexts. Key, the key space, is a finite set of all possible values that we can use as a key for encryption. These values can be both alphabetical or numeric, depending on the type of cryptosystems that we are going to use. In classical cryptosystems, the value of key was limited to the alphabet of the language on which all the communication was done. So, the rule that should be satisfied is that for every key there exists encryption algorithm which can convert a plain text to ciphertext using this key, and for any key there exists decryption algorithm which can convert the ciphertext obtained using this key into the plain text. These rules are called encryption rule and decryption rule respectively. The main condition which should be satisfied is that if we decrypt the ciphertext using the same key which was used to encrypt it, we must obtain the plain text. This rule mathematically can be expressed as it's shown here. So, types of attacks. In cryptography, breaking the cipher means retrieving the encryption key. When transmitting data, our encrypted messages can be intercepted by adversaries. Depending on what kind of information was intercepted by the enemy, we distinguish several types of attacks on cryptosystems. The first type of attack is ciphertext only attack. Of this type of attack, the enemy has access only to the encrypted messages and no other type of information. Of course, if the enemy has only an encrypted message, it is hard to retrieve any kind of information about the key. Thus, this kind of attacks is considered to be the most difficult ones. If an adversary was able to intercept several pairs of encrypted text and corresponding open texts, the complexity of this type attacks becomes lower than of the first type, since we can analyze plaintext ciphertext pair to find out this cipher key. This type of attacks is known as non-plaintext attack. Also, we can choose plaintext, which then can be encrypted, and using this pair of chosen plaintext and corresponding ciphertext, we can analyze the cryptosystem to retrieve a key. And the same can be done in adaptive chosen plaintext attacks and chosen ciphertext attacks. So, after we have defined all these terms that we are going to use during our lesson, let's move on to our classical cryptosystems. So, we will start with monoalphabetic ciphers. This type of cryptosystems is very easy to break. However, we must study them because they give us the basic mechanisms that are used to encrypt messages. So, monoalphabetic ciphers. In study of monoalphabetic ciphers, we are going to start with shift ciphers, then we study substitution and affine ciphers. The shift ciphers are the most simplest form of ciphers which were used back 2000 and 3000 years ago. Assume that the set of plaintext is given in English alphabet that is restricted to 26. Mathematically, we can express this by formula. Here, Z with subscript 26 means integers modulo 26. Modular arithmetics is a system of arithmetics for integers where numbers wrapped around upon reaching a certain value. In our case, this value is 26, and this value is called usually modulus. To understand the modular arithmetics, we can refer to 20-hour clock, in which the day is divided into two 12-hour periods. If the time is 7 now, then 8 hours later it will be 3. Usual addition would suggest that the later time should be 15, since 7 plus 8 gives us 15. But this is not the answer because clock time wraps around every 12 hours. That is, every number which is greater than 12 should be divided by 12, and the answer is the remainder of this division. We will apply the same logic to the case when we have only 26 letters in our alphabet. For that, we encode every letter of an alphabet with a number from 0 to 25. So, for numbers from 0 to 25, we can define our encryption algorithm and decryption algorithm as it shown in this part of our slide. So, since our key space is limited by 26 letters of an alphabet, we can use as a key only numbers from 0 to 25. So, we can see that the main condition of cryptosystems is satisfied here, since if we decrypt our ciphertext, which is actually the encryption of plain text, this will give us the plain text itself. So, to understand this cipher, let us consider some example. Suppose that we are going to encrypt the message "How is the weather in Bishkek today?" and we are going to use a key, as a key the number 1. So in the first line we can see our alphabet, and at the second line, since as you remember here from formula we just shift by 1, so here is our ciphertext. A becomes B, B becomes C, and so on. So if we encrypt our text using 1 as a key, the corresponding ciphertext is going to be of this form. So next, if we use the key 3, then the shift is going to be by 3 letters. So A becomes D, B becomes E, and so on. So our corresponding ciphertext looks like this. So the case when key is equal to 3 is actually called a Caesar cipher, because Julius Caesar always used the number 3 as a key. Caesar cipher can be used to encrypt words in any alphabet actually. In order to encrypt words in English alphabet, we can use keys up from 0 to 25. If we are encrypting message in Russian, for example, then the modulus is going to be equal to 33. Okay, so in Caesar cipher, or in any type of shift ciphers, an encryption algorithm just substitutes any letter by 1 occurring by the letter which occurs k positions ahead in the alphabet. Decryption substitutes any letter by the one occurring k positions backward in the alphabet. So let's consider an example. So in here in example we can see the message, the word example encrypted with key which is equal to 2 and with key which is equal to 3, and as we can see these messages are totally different. The one thing that should be noted here, this type of crypto systems is called an monoalphabetic cipher, since every letter is always encrypted into one specific letter. For example, E here is encrypted as G, and the second E also encrypted as G. So with the fixed key, one letter is always encrypted to the fixed another letter. This is the main characteristic of shift ciphers, of all monoalphabetic ciphers. So here we have exercise. You can try to find the key here. So next we are going to study some ways to break shift ciphers. Actually, shift ciphers are very easy to break. As we said before, in cryptology we call an attack on a cipher without knowing a key as a cryptanalysis. So the aim here is to find an encryption key. As I already said, in the shift ciphers, the key can be selected only from the set of numbers from 0 to 25. since for the English language the number of possible keys is limited by 26. An adversary has only the ciphertext, in ciphertext only attack. Since the key space is small, we can use ciphertext only attack as we need to try only 26 possible keys. Note that if we take key to be equal 0, we are going to end up with the message itself. So we need to try only 25 keys, not 26 but 25. So the best strategy is an exhaustive search. Another method for cryptanalysis of shift ciphers is to use frequency count. However, to apply this method we need much longer text. So the second type of attacks, as we said before, is non-plain text attack. If we know just one letter of the plain text and its encryption, then deducing the key becomes very easy, because if we have, for example, if we know that the letter T, which is equal to 19, encrypts to D, then we can just use the formula, the encryption algorithm itself, to retrieve the key. In this case, in our example, the key is equal to 10. So if we can choose plain text, then the best way to choose the letter A, because this one is encoded as 0. So 0, just counting ahead to H, then we can retrieve the key, which is 7, by counting the encoding of H. With choosing ciphertext, we can apply the same logic. We can choose a ciphertext as A, since we know that A is encoded as 0, and do the backward calculation. So next we are going to study substitution ciphers. In these ciphers, each letter of plain text is replaced by other strictly defined fixed symbol, and this substitution need not to be a shift. As we see in shift ciphers, the shift defines the rule. So when we do just substitution cipher, the key is just some permutation of letter which enlarge the number of possible keys up to 2 to power 88.